Another use of solvents is in bleaching. Some solvents are used in bleaching processes, especially in the textile and paper industries, to lighten the color of material. Okay, let's see how bleaching is done practically. This is bleaching of a batik clothes. As you can see, keep watching. That is what we start when we want to bleach the batik. Then you can apply some strings there so that it is well lapped. Yes. Once you have applied the strings, you can put it in the machine. Then you can start applying different colors. Put different colors. You can see there. Yeah, we have the ash color. Yes, we have the green color. Yeah. After finishing that process, you can apply some soda ash. As you can see, then once you apply the soda ash, you can also cover with some ice cube and leave it there for maybe 24 hours for it to dry or to mix completely. Yeah, once you are done, you can remove it from the machine and remove the strings so that you can stretch it and see how the colors have spread over the clothes. Yes, that is what we actually do when we are doing bleaching and for example for the batik clothes. I hope you have seen practically how bleaching is done in textile industries. Keep watching and enjoying. Another application is in chemical synthesis. In chemical synthesis, solvents play a crucial role. They are used in various chemical processes to react with other substances. Okay, let's now see illustration of chemical synthesis. This is the synthesis of aspirin. For example, as you can see from the video, you can mix some concentrated phosphoric acid. Yeah, as you can see, then you can put it there. Yes. Yeah, you just need to put it just above, and then you can remove the pot. Yeah, let's make some measurements there. You can put some ice, and then you can take the funnel just above the ice cubes. Yeah, you can see it is now starting to crystallize. Once done, you can add some drops of water to see what will happen. Yeah. Now, that is just a simple illustration of how synthesis can be done practically in the laboratory. So, just keep enjoying while watching. Water is the most common solvent used. It is called the universal solvent because it can dissolve many solids, and hence water is used for various experiments. Let's now see illustration of why water is called a common solvent or a universal solvent. We have 4 glasses, 2 glasses on the left, those are water, and the one on right, that is oily. And we have baking powder and salt. Now let's put some baking powder and salt in the water. Then let's stir it. Yeah, we are going to stir for some time so that you can see what will happen. Yes, keep stirring gently. As you can see, At the end, we expect the water molecules will dissolve the salt together with the baking powder. Yeah, as you can see now, salt has already dissolved in water and the baking powder has already dissolved. Let's now put in the oil. We are adding baking powder and the salt in the oil. Yeah, if we try stirring the substances in the oil, we can see, yeah, you can just keep stirring, but nothing will dissolve. Yes, just keep watching. We are now stirring the salt in oil. Let's check until the end if it will dissolve. Just keep observing. This is our practical experiment to illustrate the concept. Yeah. Now, what can you observe? Just look clearly. If you look clearly there, nothing has dissolved in the oil. The particles are still visible, but in water it has already dissolved. Why does it dissolve? It is because water is made up of some positive molecules of hydrogen and some negative molecules of oxygen. Hence, they attract other substances to dissolve in them. That is why we call water the universal solvent. Hope you have enjoyed this illustration. Let's now see about suspension. What are suspensions? Suspensions are type of mixture where small solid particles are mixed into a liquid, but they don't dissolve. Instead, these solid particles are suspended or spread out in the liquid. Imagine adding flour to water while cooking. Now, if you stop stirring, the flour particles will start to settle at the bottom. Other examples of suspensions are such as muddy water, blood, sandy particles mixed with the water, and chalk powder mixed in water. In everyday life, you can find suspensions in products such as medicine in the syrups, body sprays, and insecticides. And note that if you see a label that says shake well before use, it is likely because you are using a product that is a suspension. Sometimes suspensions can also be made with small liquid droplets or fine solid particles floating in a gas. Note that when you use an aerosol spray like a deodorant or air freshener, you are actually using a suspension in a can. So, in simple terms, suspensions are mixtures where small solid or liquid particles are floating around the liquid or air. You need to shake before you. Let's now see illustration of suspension. As you can see, we have water and oil. If you mix oil in the water, you can see some oil floating over the water. Let's now keep stirring so that you can check if it will dissolve. You can see some particles there. Yes, they are just floating above. Let's now see the differences between solutions and suspensions. Solutions are homogeneous mixtures, while suspensions are heterogeneous. Solutions are usually clear, while suspensions are not clear. Also, solutions, solute particles completely dissolved in a solvent, while solute particles settle at the bottom. And the components can be separated by evaporation, while suspension needs filtration. Now we are going to see about emulsions. What is an emulsion? An emulsion is like a special mixture of liquid that don't always get along. They do not mix completely with each other. Some liquids prefer to mix together. These are called miscible liquids, while the others prefer to stay separately. These are called immiscible liquids. Just imagine when you are trying to mix oil and water. They usually don't mix. Oil will stay above water. Therefore, an emulsion is typically made by mixing two liquids, where one is water-based and the other is oil-based. When you shake them together, the oil-based liquid forms small droplets that are suspended over the water-based liquid. The more you shake the liquid, the smaller these droplets become, and the mixture might seem like a single even solution. Now, here are examples of emulsions. For example, milk, because milk contains drops of butterfat in water. And another example is emulsion paint, which contains drops of colored oil in water. Let's now see illustration of water-oil emulsion. We have the glasses there, we have water, we have soy sauce, milk, egg. Now let's add water to the glasses. Yes, as you can see. Now, we are going also to mix with the oil. Yeah, let's just mix with the oil so that you can see clearly how emulsion is formed. Now, after that, just add egg yolk in one glass, then stir it. Yeah, I hope you can see. Yeah, it has mixed, as you can see. That is what we call emulsion. Now, let's try adding milk to the second glass. Let's now stir it. Yeah, as you can see, it has mixed a bit, but that one will form unstable emulsion. Okay, let's now add the soya contents in the third glass. That is the soya. Let's now stir it. Yes, as you can see also, it tries to mix, but it forms also unstable emulsion. So that is illustration of emulsion.